Hello Whitehill, thank you for tuning in to watch my step-by-step on how to make a simple protractor so that you can measure the angles of your rubber band launches and make sure they are consistent for your multiple trials. All you need is a piece of paper, a ruler, and a pencil. So I am choosing a piece of paper that has some nice straight lines already drawn on it for me. I'm still going to go over it though, nonetheless, to make sure they're nice and straight. I'm going to choose 6 centimeters to draw a 6 centimeter square. It's not the only measurement you can use, however, it is divisible in such a manner that makes the angles a little easier. So there's 6 centimeters, and then just so happen to go right up to the blue line, actually just short of it. Okay, so I'm going to go just short of that blue line and go 6 centimeters up to make a nice square here. And I can test to make sure that it is in fact a square by now checking this line over to the edge of the paper. 6 centimeters, perfect. Okay, so we have a square to start with. So what we're going to want to do is draw a line right through the middle. And because this is a 6 centimeter side and that's a 6 centimeter side, our hypotenuse right through the middle should be 8.48 centimeters. Let's just say 8.5 because we know the Pythagorean theorem. A squared plus b squared equals c squared. 6 centimeters squared plus 6 centimeters squared equals 8.48 centimeters squared. So because we cut this box right down the middle and these two distances are the same, we know that this is a 45-degree angle. Right there, 45 degrees. Now if we are to cut this height in half, we would have 2 equal angles from that 45, and that would be 22.5 degrees. And I'm still going to go out 8.5 centimeters right here. So we would know that this here is 22.5 degrees. The angle I really want to get though is 30 degrees. And the reason I chose 6 centimeters is because, well, 2/3 of 45 degrees is 30. So if we go up 2/3 of the way to 4 centimeters out of the 6, that is going to be our 30 degrees. You can see there's already a line drawn there from the last time I did this, but my camera was shooting in vertical rather than horizontal, so you'd have to have watched the video sideways. So I'm redoing it. So if I go out to the 8.5, now we've got 30 degrees there. Now we do the same process upwards, or on the other half, because we know that this is 90 degrees all the way up the edge of a square. We can cut, let's go with the 2/3, which would be the 4 out of the 6 centimeters there. Go out my 8.5 degrees, or sorry, 8.5 centimeters. And we know that this will be a 60-degree angle. Right there, 60. It's going to be hard to write it. We'll redo it at the end. And now if I split this 6 centimeters in half at the 3, go out my 8.5 centimeters. This will now be a 67.5 degrees. We've got 60 degrees. We've got 45 degrees. We have got, what was that one? 30 degrees, 22.5 degrees. And we know the highest point is 90. Now this is going to be sufficient. I don't think we need to divide the 6 centimeters more than that for our simple experiment. So we're going to go up 8.5. Now you might remember protractors tend to have a rounded shape, and that can be a challenge to do, because in order to get that rounded shape I have to keep the 0.0 here nice and in the exact same spot, but as I rotate it doesn't want to stay still. So I can give it a shot, or I can just do lots of little 8.5s and then connect the line in a roughly circular pattern. We already have that one, so now I'm just going to kind of keep connecting. Maybe do a couple more. And now I can cut this out. I can glue it. I can cut this out and I can glue it onto a piece of cardboard and use it to help my launcher shoot at the appropriate angles every time. So again, up here we've got 90 degrees, 67.5 degrees, 60 degrees, 45 degrees, 30 degrees, 22.5 degrees, 0 degrees. Okay, thank you for watching and happy launching.